Hi, I'm making this video for technical support at CS Labs. I have a Matsuura MC500V that I retrofit. It uses a CS Labs CSMIO IPA analog motion controller that's connected to a PC via an Ethernet cable. I've had the retrofit up and running for about 6 months, and I've really been using the machine hard for about 2. And I've noticed since day one that I can't push the machine very fast, and I cannot have the machine accelerate even half of what it could accelerate before the retrofit. From the factory, this machine should be able to accelerate at 40 inches per second. I can accelerate maybe 20 inches per second, and I can cut at a feed rate of about 70 inches per minute without the jerks, without the machine jerking so bad that I throw a PID error. And a lot of that is a lot of the settings of the machine determine whether or not you throw a PID error, and I'll show you in a moment what my settings are and how I go about setting the machine up. But essentially, I can accelerate at about half, and I can run a program at a feed rate of about half of what the machine could before the retrofit. And I think the problem is when Mach, or the machine or the controller, transitions from a straight line to a curved line, it attempts to accelerate the machine faster or slower than it attempts to accelerate or decelerate faster than what the parameters are set in Mach. So I've got a toolpath I'm going to show you for a part that I'm running, and then we're going to run the toolpath, and I'm going to kind of show you what happens when I run the toolpath. So this is the toolpath generated via Mastercam for the part that I'm cutting. And if you look here, you've got an arc, and then you've got some straight lines here. And the problem is right where my fingertip is, the tool drops down to Z depth, and then there is a little loop, and that's your entrance ramp. You can kind of see that little bitty arc there in the toolpath. Now I know that's kind of a tight arc, but I'm creating a tight arc because it really illustrates what happens. It really illustrates what happens with the controller when I try and run this type of program. Now, before I run the program, I'm going to show you in my CS Labs plugin configuration window my PID settings. This is the x-axis. And it's tuned rather aggressively right now because I was playing around with the settings. But before we run the program, we're going to auto-tune. And we're going to leave the settings right where auto-tune puts them because I think that is the easiest on the machine. So we're going to go ahead and move our z-axis to an appropriate location for auto-tuning. And then we're going to go ahead and set our rigidity at about midway here. And if you notice, my max following air is set to 3,000 pulses. You should also know that the pulses per inch for this particular axis are 84,000 roughly. 84,000 pulses per inch. So 8,400 pulses would be 1/10 of an inch. So 3,000 we'll say is about let's see here, I don't know, it's more than 50 thousandths, I would say, in terms of a following error. So we're going to go ahead and auto-tune now. This is the graph that is generated. Okay. Now, this graph is proportional. The readings on this graph are proportional to the max following error that we set right here. And if we really want to look at what's going on with the relationship of position error to actual position, we will auto-tune with the max following error set lower. We'll set it at 500 so you can get a better idea of what that relationship looks like. So we're going to go ahead and start again. You see our position error doesn't ever really smooth out, but I don't know if that's normal with this particular software. So you can see right away we threw a PID error when we tried to move at 100% feed rate with a max error, following error of 500. So we'll set this max following error at 1600, and that would be, I think, 2/1000ths of an inch if my math is correct. Maybe I'm wrong. Maybe that's 20 thousandths. Let's see here. Yeah, that's 20 thousandths. So you see we get kind of a high max error. So just to be safe, just so that you can see what's going on with the toolpath, when I run the toolpath, we're going to set this back at 3000. We don't want to trip a PID, we don't want to throw a PID error when we're running the toolpath. We want to actually see what the machine is doing. So that was the x-axis. I'm going to go ahead and close this out and retune the y-axis, because the y-axis is also set a little aggressively too. Just need to move the axis back to an appropriate position. And we will set the max following error at 500 again, so that you can see in the graph the relationship you can see the relationship between the following error and the position, between the position and the position error more distinctly. Okay, yeah, so real ugly position error. And once again, we've got to set our max following error at 3000 because we'll run the machine at a feed rate of 100. We'll jog so that you can see the what the max error comes out to be. So the max following error at 100% feed rate is over 3000, so much that it tripped the PID error. So we're going to set this at 5000 just to run our program, just so you can see what the machine does. Now before we run this program, I just want to add that I have tuned and retuned and tuned again these servos so many times. I'm kind of tired of it, and I don't think it's a servo tuning issue, because no matter how I tune the servos, whether it's tuning the relationship between the CS Labs plugin and the servo packs, or the relationships between the servos and the servo packs themselves, nothing seems to help. So I think this is a controller issue.
with the CS Labs controller. I think it attempts to move the axis faster than what the settings are in Mach. And these settings that I'm setting the machine at are the advertised settings of the machine. They're the OEM settings. It's I think it's 40 inches per second is what my motors in the X and Y direction are supposed to accelerate at, and the max velocity is 480 inches a minute, and that's what I'm set at in Mach, and that's what the machine was advertised to run at. So we're going to go ahead and run our program. Okay, so we're running the program. I've got the coolant and the spindle turned off so you can kind of hear the axes better. But there's definitely some jerking motion. I could put my hand on this vise and I could feel the machine jerking and oscillating. It's not throwing a PID error yet because I have the max following error set to, I think, 20 or 30 thousandths. Possibly even more. But you can really feel the machine jerk. I think in a minute here. I ran this program again and it's going to get to the more challenging part of the program and it will actually throw an error. Yep, just threw a PID error. I really can't tell which axis. I don't really get any data on this page. So there you have it. That's what happens. It throws PID error even with my my max following error setting set really high. This is my general configuration page, just to kind of give you an idea of how I have the machine set up. These are the constant velocity settings. Obviously, none of those are clicked. I'm definitely in constant velocity mode. So there you have it. I'm going to cut the video off here. Hopefully you guys at CS Labs can look at what's going on and maybe help me out. Like I said, I've had the retrofit for about 6 months and I've really been pushing the machine hard for 2 months. Not pushing it hard, but actually using the machine. And I can't run it faster than 70 inches per minute. And I can't accelerate more than 20 inches per second. And those stats, that's half of what the machine could do before the retrofit. So using the CS Labs controller, I can only move and accelerate half of what I could do before. So hopefully you guys have some advice and maybe can help me out. If you need any more information, send me an email and I can make you a new video or send you files or whatever you need. Thanks.